in Chapter 8 of the 5th unit in Financial Math 1, and it's under Driving Safety Data. Today we're going to calculate the reaction time and distance in the English Standard System. We're going to calculate and use braking distance in both English Standard and metric systems. And we're going to calculate the total stopping distance in both the English and metric standard system. So let's look at the first example here. Hopefully you've already gone through all the vocabulary, and we'll kind of re-emphasize that as we're going through the lesson. It says, what is the reaction distance for a car traveling approximately 48 miles per hour? Now, when we're talking reaction distance, you should know that research has determined that it's approximately 0.75 to 1.5 seconds for somebody to react. And when we talk react, that's for them to go from the gas pedal to the brake pedal. That is what's known as the reaction time. And so a car traveling, we're going to say right now about 55 miles per hour, travels in about 81 feet per second. So you're probably wondering how I got that. Let's go to that real quick. All right, here we're going to kind of go through this section right here. It says there's 5,280 feet in 1 mile. A car traveling 55 miles per hour will cover 55 miles in 1 hour. 55 miles times the feet of 5,280 means that they're going to go 290,400 feet in 1 hour. If we take that and divide it by 60, we're breaking it down to 1 minute, which is 4870. And then if we divide again by 60 to get those minutes to seconds, we see that it's pretty close to about 81 feet per second. So that being said, we're going to look in here at a general rule of thumb. Let's kind of go through here first, and we're going to calculate what the distance is for both a person who reacts quickly at 0.75 and a person who reacts what they would say a little bit slower at 1.5 seconds. So we're going to take and create a proportion, and it is basically the feet over the seconds. So 81 feet to 1 second. How many feet do we go in 0.75 of a second? Now when we create a proportion, we then cross multiply, and we end up with x equals 81 times 0.75, which gives us then 60.75 feet. So someone who has a very quick reaction can react in 3/4 of a second. They're going to go 60.75 feet before they get from the gas pedal to the brake pedal. Now let's look and see what would happen if it was somebody who was a little bit slower. So again, we've got our feet over our seconds, 81 feet over a second, and that equals x over the person who goes 1.5 seconds. So again, same process, cross multiplying, and it's going to be x equals 81 times 1.5. And then that would be 121.5, which is exactly double the person going 1.5 or going 0.75, which makes sense because 1.5 seconds is double of 0.75. So the reaction distance for a car traveling 48 miles per hour, we're looking at approximately 60.75 to 121.5 feet. Now you should know a general rule of thumb here is that a reaction distance equals 1 foot per mile per hour. So it's 1 foot per hour of speed. So that being said, take just a second and read through this and see if you can determine about how many feet are they going to go going 65 miles per hour. And if you said that it is 65 feet, you would have been correct. So the general rule of thumb is that your reaction distance is equivalent to 1 per mile of speed. So 65 miles per hour, they're going to go about 65 feet in their reaction distance. Example 2, what is the approximate braking distance for a car traveling 48 miles an hour? Now, reaction distance was that time going from the acceleration pedal to the brake pedal, and the braking distance, your foot has hit the brake pedal, and it's the distance you go from the second it hits the brake pedal to when you stop. And we do have a formula for the braking distance, and it looks a little bit like this. It's the speed squared divided by 20, and that's our formula. So if we plug in 48 miles per hour into that formula and we square it, we end up with 2,304 divided by 20, and when we multiply or divide that out, we get approximately 115.2 feet. So very simple formula, very easy to use, so I want you to go ahead and give it a try. Looking at this question, it says, what factors also need to be taken into account that might add to or subtract from the braking distance? And some of the things that have come up in classes that we've had that are in-person classes are things like road conditions. Are they good road conditions? Or are they snow conditions or ice conditions? Is there rain going on? Is there construction going on? So those are many, many different factors with regards to road construction or road conditions. We also need to look at, we've learned that brake efficiency. How good are your brakes? Are they wearing down? Are they old? Or are they brand new? What about the tire pressure? Do you have your tires at the correct pressure so that it can have its maximum impact with stopping? And then finally, what about driver impairment? If a driver is impaired, it is shown, research shows, that their reaction time is stunted. So those are all things that can be impacted. Now it says Rachel's driving 48 miles per hour on a one-lane highway. She sees an accident ahead of her 200 feet. Will she be able to stop? So in this case, we're talking what is her reaction distance plus her braking distance. Well, we already determined reaction distance is approximately the same as the miles per hour. So that's going to be 48. Plus, we learned a formula, which was the speed squared divided by 20. So that gives us the braking. And the total of all that is going to give me my total reaction time, or my total stopping distance. So looking here, I've got 48 plus the 48 squared divided by 20 gave me the 115.2. I saw that from the last example. So it's going to be a total stopping distance of 163.2 feet. So the answer is yes, she will have time. Please press pause, solve this, come back when you're ready. All right, let's see how you did. So it says here that this car was traveling 65 miles per hour. So I know that my reaction distance is going to be about 65 feet. Plus, plugging into my formula of speed squared divided by 20, I know that I'm looking at about 65 plus 211.25 feet for a total stopping distance of 276.25 feet. All right, last example. Desiree is traveling through Canada The speedometer is read in kilometers per hour rather than miles per hour. She knows that 1 kilometer is approximately equal to 1,000 meters, and 1 meter is a little bit more than 3 feet. Determine her total stopping distance if she is traveling 88 miles per hour, kilometers per hour. So one thing I need to remember is 1 kilometer, we learned this in the last chapter, is 0.621371 miles. And that's going to be a good place to start. If I look at this, I've got 88 miles, or kilometers, times the 0.621371 gives me 54.68 miles per hour. Now I'm going to go ahead and plug that into the formula that I know. So I'm looking at 54.68 plus that 54.68 squared divided by 20. When I get that, I get 54.68 plus 149.5, which equals a total stopping distance of 204.18. I know that 1 foot equals 0.3048 meters. So I'm going to take the 204.18 and I'm going to multiply that by the 0.3048. And I get 62.23 meters. Now, one thing you should know, there is also a formula for calculating it in meters. And that's going to be, our formula is over here, and I'll write it in different colors so that it stands out. Speed squared divided by 170 plus the speed divided by 5. So using that, let's take that 88 kilometers per hour and plug it in and see what we get. We've got 88 squared divided by 170 plus 88 divided by 5. And when you plug all of that in the calculator, you get approximately 63.15 meters. You can see very, very close to the 62.23 that we got before. All right, please take a second to solve this. And remember to solve it in meters. Come back when you're ready. All right, hopefully you found that the formula that we just learned is probably the better route to go because we're looking to do this in meters and it's already given it to us in kilometers. So we're looking at using this formula, remembering that S equals speed in kilometers per hour. So plugging it in, I've got 78 squared divided by 170 plus 78 divided by 5. And when I plug that into the calculator, I get approximately 51.39 meters. How'd you do? All right, good job on this lesson. One more for this unit.